When scientists studied fossilized dinosaur eggs, they found an amazing secret inside their shells.
But before we start, please make sure to subscribe and hit the bell so you never miss an upload from us. Also, leave a like right now.
Millions of years ago in the Gobi Desert of Mongolia, some dinosaur embryos were frozen in time. Eventually, against all odds, they made their way to the vaults of the American Museum of Natural History in New York. Now, scientists have been using a new approach to take a closer look at them. And what they found could change what we know about dinosaurs. Up until now, the science surrounding dinosaur embryology had remained a mystery. Over the years, in fact, researchers have been unable to establish just how long it took for the ancient creatures to hatch. But thanks to some new research led by Florida State University, this riddle may have been solved. Gregory Erickson, a biology professor, has been examining embryos belonging to a pair of different species of dinosaur. And by establishing their age, he and his team have reached some fascinating conclusions about how dinosaurs lived and reproduced. In fact, their discoveries could even shed light on the mass extinction that wiped these creatures from the earth. The science of paleontology began around the mid-19th century, when researchers in Britain noted dinosaur bones for the first time. Before long, they theorized that these creatures reproduced in a manner similar to modern-day reptiles. However, it wasn't until later in 1859 that the first fossilized dinosaur eggs were discovered. Uncovered in France, these giant fossils were incorrectly identified as belonging to a species of bird. As such, they were overlooked for a long time. In fact, it would be another 64 years or so before experts successfully identified a clutch of dinosaur eggs. This time, the discovery was made by researchers from the American Museum of Natural History working in Mongolia. From that point on, dinosaur eggs started to emerge from every corner of the world. But what are the creatures that once inhabited these shells? While some of the fossils had formed after the creatures inside had successfully hatched, others told a different story. And in rare cases, the tiny remains of developing creatures had also been preserved. Before the discovery of dinosaur eggs, little was known about how the creatures developed inside. But now they had access to fossilized embryos. Experts were able to begin theorizing about this process. And over time, many of them concluded that the incubation process was similar to that seen in today's birds. But in 2013, Montana State University's David J. Verrocchio published a paper which proposed an alternative theory. According to him, certain dinosaur eggs were equipped with pores, suggesting that they were covered up underground. In turn, this implied that the incubation process had more in common with that of modern-day reptiles. Without any definite conclusions, however, much surrounding this area of paleontology remained a mystery. In a 2017 statement from Florida State University, Erickson explained, "Some of the greatest riddles about dinosaurs pertain to their embryology. Virtually nothing is known. Did their eggs incubate slowly like their reptilian cousins, or lizards, or rapidly like living dinosaurs, the birds?" Hoping to answer this question once and for all, Erickson decided to take an interesting approach. Apparently, just like humans, reptiles produce a substance which is known as dentin on a daily basis. Found in the teeth, this tissue mineralizes into a tough core that builds up layers over time. Thanks to this process, researchers are able to determine the age of some organisms by looking at the layers in their teeth. As Erickson told the Washington Post in 2017, you can basically just count those up and figure out how long it took dentition to form. In fact, he likens the approach to noting the rings of a tree to establish how long it's been alive. With this technique in mind, Erickson started to wonder if the embryos of dinosaurs could be studied in this way. And so he reached out to experts at Canada's University of Calgary and the American Museum of Natural History in New York. Basically, he wanted to see if there was a way to test his theory. Despite the fact that fossilized dinosaur embryos are extremely uncommon, both institutions were able to assist Erickson in his research. At the American Museum of Natural History, researchers unearthed a dozen eggs that had been discovered in the Gobi Desert in Mongolia. According to the experts, they belonged to the species Protoceratops andwersi, a creature related to the Triceratops. And not quite 7 ounces, these eggs were relatively small, roughly the same proportions as a potato. However, the other specimens that Erickson was able to get a hold of were in a totally different league. According to the Canadian province in Alberta, they belonged to a dinosaur known as Hypacrotius stebigeri. Capable of growing up to 30 feet in length, the duck-billed Hypoceras laid eggs that weighed almost 9 pounds. Visually, they could be described as having proportions roughly the same as a volleyball. But though these specimens were very different to the ones found in Mongolia, they yielded similarly exciting material for Erikson. Within both sets of eggs, researchers had discovered the fossilized embryos of dinosaurs. But could Erikson use dentin analysis to learn about their age, and thus the amount of time they might have taken to hatch? Working as the head of a team of researchers, the professor set out to find an answer. First, Erikson and his team used a CAT scanner to look at the dentition present in the embryo's jaws. Then they removed a number of teeth from the fossilized remains. Using microscopes, they were able to zoom in on the ancient specimens to find exactly what they'd been searching for. Underneath the microscope, the lines of dentin in the teeth were clear. As Erikson told the Washington Post, "I knew we were in business." Now it was possible for the team to determine how long the embryos had been alive. We could literally count them and see how long each dinosaur had been developing, as he explained in the FSU statement. For the researchers involved, it was an exciting development. In the same statement, Erikson's co-author, Dara Zelenitsky, explained, "Time within the egg is a crucial part of development, but this earliest growth stage is so poorly understood because dinosaur embryos are rare. Embryos can potentially tell us how dinosaurs developed and grew very early on in life, and if they're more similar to birds or reptiles in this aspect." In fact, as a result of the study, Erikson and his team were able to acquire solid evidence to suggest how long dinosaurs like Hypocrosaurus and Protoceratops took to hatch. And according to Erikson himself, it's the first time that such a conclusion has been reached. So what exactly did they learn from these ancient remains? Well, the team were able to calculate that somewhere close to 40% of the embryo's incubation period could have been spent developing teeth. As such, they estimated that these dinosaurs took a long time to hatch, perhaps double the amount of time compared to avian eggs of much the same size. Specifically, the team discovered that the smaller Hypocrosaurus could have taken approximately 3 months to hatch. Meanwhile, the larger Protoceratops may have spent as many as 6 months developing inside the egg. Apparently, it's the first time that researchers have been able to pinpoint specific incubation times for non-avian dinosaurs. But that's not all. Hypocrosaurus was undeniably a sizable dinosaur. It was far from the biggest. And because modern reptiles and birds indicate that larger eggs take more time to hatch, it's likely that some creatures had a much longer incubation period. In fact, Erikson believes it could have stretched to as much as 12 months. "It's really surprising," Erikson told the Washington Post. "I don't think that people would have entertained the idea that they would have incubated over the better part of a year." However, for Verricchio, who'd long believed that dinosaur reproduction was more similar to that of reptiles than birds, the news was less of a shock. In modern science, it's generally believed that birds are the closest things to dinosaurs that are alive today. As such, it's not surprising that many experts have deduced that their reproductive process might be similar. However, thanks to Erikson and his team, it can now be theorized that the creatures of the Mesozoic era actually had more in common with reptiles. Typically, bird eggs have a relatively short incubation period, with embryos usually taking between 10 and 30 days to emerge from their shells. Even emperor penguins, whose young take the longest to hatch out of any avian species, spend just 2 months developing. However, modern reptiles are a different story. Regularly referred to as cousins of the dinosaurs, today's reptiles have an average incubation period of between 1 and 2 months. But it's not just the time that it takes for their eggs to hatch that's different to their prehistoric relatives. Apparently, the way in which they interact with their developing young is also at odds with the dinosaurs. Unlike most birds, today's reptiles are known for burying their fertilized eggs underground. And while some species will remain with their young in order to protect them, the vast majority abandon them to fate. But if dinosaur eggs took a similar time to incubate, did they also engage in such a detached approach to parenthood? Amazingly, there's evidence to suggest that dinosaurs, unlike modern-day reptiles, remained with their young throughout the incubation period. According to Verricchio, previous research has indicated that parental care existed within some species. However, this typically related to those with eggs that were limited in size and likely took less time to hatch. But if some dinosaur eggs took the best part of a year to hatch, that would have been a long time for the parents to remain in one location. Of course, their presence would have protected their young and prevented them from being eaten by predators. But might this lengthy incubation period have actually contributed to their ultimate extinction? Interestingly, the discoveries made by Erikson and his team have called many pre-existing theories into question. For example, it's long been suspected that some dinosaurs spent the warmer months in the Arctic. Then this line of thinking goes, they would have migrated south to Canada for the colder part of the year. But now such a journey seems improbable. Given the time that it would have taken some dinosaur embryos to develop, it seems unlikely that the creatures would have migrated at all. Moreover, it wouldn't have been easy for the adults to choose a site for their nests. Because the eggs took so long to hatch, it likely would have been necessary to find a spot that could be looked after for a long period. But those weren't the only difficulties associated with tending to a nest of eggs for an extended time. By staying in one place for months, dinosaurs may have made themselves more vulnerable to starvation, natural calamities, and predators. In short, they were already at a disadvantage when disaster eventually struck. Somewhere close to 66 million years ago, scientists believe an asteroid dramatically collided with our planet. Afterwards, it's thought that debris from the impact filled the atmosphere. This would have prevented light from the sun from reaching Earth. In the ensuing darkness, temperatures plummeted, and ecosystems were thrown into disarray. In the end, scientists believe this event led to the extinction of 75% of living things on the planet. Meanwhile, the creatures that did survive likely did so by being adaptable and fast to reproduce. For example, the progenitors of contemporary birds are thought to have had short incubation periods. This would have allowed them to quickly repopulate the stricken planet. But with their slow incubation times, creatures like Hyperchrysaurus and Protoceratops wouldn't have found it so easy to reproduce. In the statement from FSU, Erickson explained, "We suspect our findings have implications for understanding why dinosaurs went extinct at the end of the Cretaceous period, whereas amphibians, birds, mammals, and other reptiles made it through and prospered." But although Erickson and his team believed that the dinosaurs' slow incubation period may have stood in the way of their survival, it wasn't the only factor. Apparently, these lumbering creatures were also disadvantaged in many other ways. For example, as large, warm-blooded animals, they were terrible at conserving energy. Aside from that, Erickson claims, the dinosaurs also took a long time to mature, even after they'd finally hatched. All in all, evolutionarily speaking, these creatures were not particularly well equipped to handle change. And when their habitat drastically altered, they had little to help them adapt to the new world. The dinosaurs found themselves holding some bad cards. Erickson told the New York Times in 2017 they had a dead man's hand. Now, millions of years after the mass extinction, creatures like Hyperchrysaurus and Protoceratops have long since vanished from the Earth. But thanks to researchers like the team at FSU, we're still learning more about them every day.